with you with that on the Teams. Let me see if I can share what I have. Okay. Okay, please again confirm it to me. Can you see the screen I'm sharing? This is, by the way, are you from PHYV 101 or FVV? This is what the PHYV student has wrote last week. Therefore, let me see if you raise your hand, somebody, if you could see what I'm sharing. Yeah, thank you, Lufantia. That means good. Then I don't know where was that question, and if I bring it in as it is, this is actually the question. I just copy pasted on a PowerPoint. This is, as I said, from PHYV 101 that they wrote last week. These are the questions that I will be going in. Whether you are from FVV or PHYV, you should able to be benefit from our discussion today, especially those of you FVV students who will be writing tomorrow, or I don't know when exactly. You guys will be kind of, if not similar or not the same though, basically similar questions you would anticipate. Therefore, what we'll be going through should benefit you. Then with what that note, basically the first one is very simple. What type of power does each of the following prefixes, this is, you could see there that the following prefixes represent? Then if you are given such condition, remember prefix is something that the fix is in front prefix. Femto, it says what is it? I hope you remember this thing is from units and the measurement, unit 1. Femto, this should be very easy for you. Therefore, this is 10 raised to minus 15. You can't say just minus 15. You must able to put 10 raised to minus 15. Okay, therefore careful. If you just write the minus 15, it doesn't mean that you are correct. It must be an exponent, 10 raised to something, minus 15 in this case, femto. And if I go just down, mega, you know this one is 10 raised to 6, megabyte, kilobyte, 10 raised to minus 3, mostly with data, we know these ones. Pico, what do you say? Pico is also very small. It is 10 raised to minus 12. You see, picometer, the small nanometer, 10 raised to minus 9. Or it is there even if in terms of meter. Nano is 10 raised to minus 9. Pico is 10 raised to minus 12. Femto is 10 raised to minus 15. You could continue up there. What about deci? I hope these ones are what daily, every day we use, 10 raised to minus 1. And giga, again something big, you have to be also happy with this one. This is 10 raised to 9. The difference between these two is basically one is 10 raised to 9, the other one is opposite, 10 raised to positive 9. Gigabyte, you see the memory stick we have these days. We have in terms of giga, big. It used to be mega. Mega is small now. Mega is actually 1000 less than giga. Therefore, for the PHEV 101 student, this is a free gift, 3 mark. What do you make a mistake here? Simply basically this thing, knowing what are these exponents are. I'm not expecting any question from this side. Let me just check if these YouTubers are also happy with it. Yeah, warning, the streaming, Yeah, currently there are actually 5 viewers there. See. Guys, sorry, I'm supposed to be coming back to you. That means you are also following up us here. Please, if you have a question, I'm gonna keep my eye on the YouTubers. I'll be keeping it on the other window. I will see if you guys have any question. Please comment. Okay, I'm gonna just say hi. I will be hoping that I will pick up your question if it comes quickly. Therefore, that's where you are. Let's continue. Teams also, on the Teams, people on the Teams, a couple of you, I can't count, a couple of you in front of me. If you have question, you interfere me. You could switch on your mic and then you could start speaking. I'll pick you up in between. Please don't hesitate to discuss though. Okay, let's go. What is the question number 2 all about? This is a vector equations. If you think of it, this is what you did in chapter 1 and 2 again together. It's a vector calculus. Basically, you have to decompose the final or the displacement of the individual vectors into pieces until you get the final result. The question says the following: is a golfer who hits the ball from the starting position. This is the starting position. The ball is started there, let's assume. Then, because this guy is not that good like me when I play, I never play golf, but if I think of going to play, I know this is a kind of pass out anticipate, you know what I mean? It's going to be ups and downs. Check what happened. The golfer hit from the starting point, then the first hit took him down by this angle, a distance of 285 meters. Then from that point, if there is a tree actually, something hit down, okay, let's say, and then it go past this length. Then the third will go that past 170. And then the last one, the 6 meter. We are given at each point the displacement of the individual vector as well as the angle are given. Therefore, the objective of the question is then the ball bounces some distances, as I show you down, which with the question asks, what if this guy would have hit a single pass down there? This is the resultant pass. Therefore, the question is, how do you find this resultant vector R? It must have a magnitude. It must have a direction. What you would have done? That's what I know. A notice I put for you, because this thing is ups and down. I need a lot of calculation is going to involve. That's why I'm writing it here. The other questions I don't have the solution here, but you can go with me. Say what I said is there is a direction of each arrows. My arrow is the first one. The arrow is down. It will run there. The second arrow is up. The third vector, the arrow is down, and then the fourth one, the arrow is indicated. Then the objective, or the simplest way I will give you, is you have to decompose each vector into their x and y directions. And remember, we have got 1, 2, 3, 4. Therefore, we have 4 vectors. Both magnitude and direction is given. Resolve each vector in their respective xy component. Then find the resultant x and the resultant y components. Why don't you do that? Let's do one by one then. Let's see. Let's take this vector, the very first vector. Before I go there, remember the angle. I have to specify this one. Angle, how do we measure an angle? If this is an x, y coordinate, I hope you guys know about it by now. Do you know that the angle is always measured from x-axis going that way is a positive? That's a positive angle. Therefore, 0 is here, 90 degrees there, 180 degrees if you come all the way, 270 degrees, and then 360 degrees. This point is 270 degrees. We always measure reference from x-axis. With that in mind, for each of the vectors, we have to be careful when we choose our reference angle. What I mean here, let's go forward and then I'll show you. Let me zoom this one out, and then I wish I can hide some of them. Look, this is, just concentrate here. Concentrate on this diagram. I'm interested only on the first one. I call this one vector 1. This is my vector 1 now. It is going from that origin, x and y coordinate, and then it passed to that distance. Then I say, okay, this vector must be from this point up to this point. This is my theta. Because the angle started from origin, or the x-axis, which is the origin in this case, and then I must go all the way where the vector is. Then I could see from that point to this point is 180, from that point to all the way here is 270 degrees. Then this angle actually did not reach 270, then it is 270 minus 30 degrees, 240. Are you happy there? I'm checking those on the Thank you for the liking. Those of you on the YouTube, thank you. I could see. Those of you on Teams, are you also following? No problem. Thank you, Vanessa. Okay, good. I could see. Therefore, let's continue then. We know the angle. Then let's decompose this vector. This is d1x if you see in terms of d1y rather. And then this one is d1x, the x component, and then the y component of that particular vector. If you're thinking, what is this guy talking? What I mean is, this is a vector in the third coordinate, and then you know this angle is from here to here is, which we get 240 degree. And then if you decompose this vector into x and the y, what I mean is the x component is going to be this one, the arrow must be that way, the y component must be this one, x and the y. How do I get the x and the y component of this vector then? It's a definition. The x component is mostly the cosine, you know of. Then dx, I say d1 cosine of theta, and which is 285 is given, cosine of 240, I put together, this is my answer. In the same way, the y component is the sine, I put together, this is my y component. The strategy is what makes nice. You have to thoroughly decompose this one into its corresponding x and y. Of course, you could see now the second vector, which I'm talking about, this particular small vector, she is small, that's why I took it to this side. Then I have to be careful again, what is the angle given? If you see, this angle is actually horizontal. It starts from 0, let me change my pen. Start from 0 and then all the way there. Okay, therefore it was 180 all the way, but 62 degree. You see, my drawing is not right. Yeah, like this. My drawing is, the angle is this one. This is angle theta. Therefore, the overall is 180 degree minus the 30, which is, no, what is that? 62, I'm looking up. 62, therefore this is your angle. If you know your angle, you know the magnitude, just put together, the x component is going to be 7.98, it's a cosine. The y component is a sine. Careful when you're doing this thing. You must make sure that, where is this x sine and the cosine coming? Remember, this is about a triangle. Just in case you have no idea what I'm talking here. You see? If this angle is theta, this one is a y, and this one is x. Remember, sine theta is opposite, which is opposite is y over the hypotenuse h. And the cosine of theta is the adjacent, which is x over hypotenuse h. Therefore, the y component is mostly defined with sine. The x component is mostly defined by cosine. That's where it is coming. But make sure you put your values together in your calculator and then get this is the y component, this is x component. Of course, you could see, if I go back to this point on the very first one, the y component is down, the x component is to the negative. You could see both of them are negative. On the second path, that is a small path there, which is 62 degree relative to negative x-axis with 70 meters, is actually up. Because it is up, the y component, you see, this arrow is wrong. The y component is supposed to be up that way. Yeah, it's right, it's up. The y component is up, the x component is to the left, therefore the y component must be positive, and the x component must be negative. Then it is good. It's, you see, the values are here. I'm hoping you guys, you're following up. If you're not, you would have stopped me. Oh, somebody raised the hand. Please. I can't see. A couple of you. Somebody on the Teams has raised the hand. Who is it? Let me go back. Petros? Temba? Temba? Yeah, you're welcome. Yeah. Please go on. Look, it's a good question. I better keep it within 2. You know why I didn't round off now? it is, you see, if you start rounding off whilst you're busy calculating, you might run into trouble. You are not gonna be, you are not gonna be penalized. You're penalized, or if the lecturers have indicated to you is, let me go back one step. You see here also, I was not given any decimal place. You see here there is no decimal. Here there is no decimal. Here there is no decimal. You see what I'm talking? It is better, my suggestion to you, it's not about being penalized. It is better for you to keep in a certain format. For me, for example, I kept with two decimal places here. But at the last minute, you know what I mean? Last minute, I will check how many significant figures do I have. My answer should be to the least significant figure I have got in the measurement. Therefore, I don't penalize you. It is personally me. I don't penalize you. Lecturers also, they didn't tell you. Here, nobody told you that your answer must be within these decimal places or within these significant figure. But the rule is, even if the lecturer didn't imply, the rule is you have to express your final answer in based on the least significant figure you had in your calculation. In this case, it's a 1. You mean, for example, let's go back. I wrote 142.50. What do you want to write? 143? Continue. Look, I suggest to you at least take two decimal places. Otherwise, you're going to spend the day writing. Then be consistent also. Be consistent throughout your calculation. If it is show, they're going to ask you anyway to show how did you arrive to that final equation. You could say, look, yes, I have been consistently living with two decimal places. I'm going to go down. I don't know if I took care of what you're speaking now, but it is good to have a consistency when you're calculating such a thing. Thank you. Yeah, let's go for it. Therefore, guys, let's go back. I finished 1 and 2. We're going through now. What about the third? What the third is basically now from that point down to this point. The angle given is below x-axis 25 degree. Then what I did is, okay, then if that is the case, the x component is going to be down. No, a lie. The y component must be down. The x component must be to the right. And then I must be careful now. What is my angle? The angle gonna be, you see, from that point all the way there. Then it's almost a 360 degree minus the 25. Of course, you could see what I put there also. The overall angle, therefore, 360 minus 25, which is 335 degrees. Then I put together my d3x is positive, my d3y is negative. I'm not going through this number. You could easily see where these numbers are coming. Then you could also notice that the x component is positive, true, the x component is to the right, the y component is down. Then done. The last one, the last path is from that point down 6 meters. The angle given is that one. Then my vector should be measured from origin, from the x-axis, all the way there again. Therefore, you could see this angle is 130 degree. If you make a circle, it's 360 degree, but 130 away. Therefore, you have got 230 degree. Again, put your calculator together. This is 6 meters, the hypotenuse 6. The x component, they're supposed to be d4 cos theta, yeah, d4 sin theta. Then I put together, this is my answers. I have done the majority of the job. I have almost done. Then the next is just sit down and then type each of them. The x component, d1x plus d2x plus d3x, d4x. Then if you see, I put together, I got that small number, minus 0.27 meter. the y component again, I've got this all. You see, my final answer in this case, therefore, is 308 meter. That is the smallest I could go. And then the angle also, you could see one. Oh, by the way, if I'm rushing, please stop me. You see the x, you add up all of them, you add up all of the y component, you put under the square root. This is a resultant vector. This is Rx. Negative, because it's negative, it's to the negative direction. Ry is also negative, but the drawing is not good. The drawing is supposed to be like down in such a way that this angle actually big. You see the x component is small, the y component is such big. Of course, you could see the theta is the angle, that angle theta is tan inverse of the y component divided by the x component, which is this over that. I got 89.95. It's almost 90 degree. Of course, you could see the x component is small, the y component is such long. It's as if it's almost straight down. Okay, if you see here also, the guy start kicking there, instead of going such circle, you could have gone. That means this is actually the displacement R. You see, this angle is the angle we just calculated is 89 degrees, that's 90 degree, this angle, almost 90 degree. But the overall is 269.95. I'm going to round off to 270 degree. Any question here? Especially those of you from PHYV, not PHYV, FVV students who are yet to write this test. Are you okay with this question number 2? Or those of you PHYV also student, this is also part of your TEMBA, thank you. This is also part of your exam by the end of the semester. Therefore, you should able to solve such sort of question. And I'm holding in case, let me just check my YouTubers. What do you guys say? There is a problem with the network, not receiving enough data. Our university internet is becoming slow, and it's not going. But guys, those of you on the YouTube, sorry, but it will resolve through time. I could see there is a yellow warning on it saying that the data is, or the streaming is not smooth, but hopefully to resolve soon. On the Teams, going back to you, I don't see any comment up to now. I'm checking also if somebody don't want to speak, but just want to send some sort of message. I checked there also, looks all right. If not, guys, speak out. If otherwise, I can't know if you understood or no. Looks like easy though for me. If I go back to the question, or if you are just don't know what to do with this one, what I suggest to you is just understand that your vectors, decompose them into their pieces. Somebody want to speak? Yeah. Previous meaning here. Let me clean for you, yeah? Yeah. Oh, you mean what? How do you know those angles? Let me take you back. Remember that it starts here. Always put this one in your head. Angle is measured relative to x-axis. Therefore, anything on the x-axis is 0 degree. Anything on the y-axis is 90 degree. This is the angle we're talking. Anything on the negative x-axis is negative 180 degree. Anything on the negative y-axis down is 270 degree. Therefore, if you make a big circle, again, the x-axis ended up 360 degree. This one is the first understanding you need to make. 2. Then, with that knowledge, come to this vector number 1, for example. That is a first vector. And then, put your origin there. That origin is the same as to the origin we're talking here. Then draw or an angle from x-axis all the way there. Then by now you should see, I don't know how far I go in the third quadrant, but I was given that this angle is 30. If I would have reached there, it is 270 degree. Then, but I didn't reach there is minus 30. That's why this thing is 270 minus 30. Let's go there. Again, I'm gonna put my cursor there, my XY coordinate there. And then I'm gonna start measuring from that point all the way 180 degree. And then this thing is not given. You see that angle is not given. What is given is this one. Then I'm gonna go all the way to my vector. Then I say, okay, this would have been 360 degree. Then I say 360 minus whatever is left, which is given 130 degree. Then I know by then this angle is whatever I get from this expression. You pick it up. I don't want to confuse, but I could tell you there is other option also. You see there is other option, but it's going to confuse you. You know what I mean is, let me give you. Think of which coordinate this one in, the first one, the first vector. In which coordinate is it? In the first, second, third, or fourth? Remember, this one is the first coordinate, this one is the second coordinate, this one is the third coordinate, and then this one is the fourth coordinate. In the third coordinate. In the third coordinate, is sign positive or negative? Is cosine positive or negative? Then, if you know those all also, you could have used, instead of 240, you could have used angle 30, here also 30, but make sure that you know where you are. You see, but this thing is gonna keep so many information in your head. It's better just to start with XY coordinate as origin, and then measure an angle from x-axis all the way where the vector is, and then take that one as your angle. You have? Yeah, you're welcome. Any other? Let me check those off on the YouTubers. The internet is bad. Warning again. So many people are struggling to connect to. Sorry, YouTubers. Okay, teams, let's continue. Okay, we agreed there, we agreed here. Let's go. This is question number 3. I think this is a gift for me when I read through the questions, or I was also part of the invigilation on that particular day, moving in the class, and I thought of, this is a gift for an engineering student. Think of the question. It's an object which is past is described by the following equation. X as a function of time is given. This is the position of the object is not known. It depends on time. At t is equal to 0, for example, it's 2. At t is equal to 1, it's going to be 2 plus 3 plus 2 plus 3 is 5, 5 plus 1 is 6. It's going to be 6. It is time dependent, you see. Then it asks us the question is, question number 1. What's the position of this object at t is equal to 3? This is a 1 plus 1 question, basically. What I mean is, then I know x of t is given by 2 plus 3t squared plus t raised to 4. Then x of 3 would be, when t is equal to 3, would be 2 plus 3 into 3 squared plus 3 cubed, 3 raised to 4. The rest is mathematics. Then I would have said that, okay, this, I don't know what you guys say. This is 2 plus 3 squared is 9. 9 times 3 is 27. And then plus 3, just add another by 3. If I know this is 3 raised to 3, this is 3 raised to 4, it's going to be 81. If you know what I'm talking. 3 squared is 9. 3 raised to 4 is 81. 3 raised to 6, you guys, you have calculator basically if you don't have it in your head. Then, if I put this one in number, therefore this should be about 100, and then how many? One left, okay, 110, I believe. Yeah, around there. 1 plus 7 is 8, 8 plus 2 is 0, yeah, 110. Why you struggle then? This carries, I don't know how many mark. Took 6 mark. I forgot to update you. The first one actually carries how many mark? Where do I have? 9 mark, you see. This is also kind of not a gift per se. It needs a little bit of ups and downs, but this one is actually the easiest for me. Yeah, done. X is equal to 3. And then question number 2 asks us, what is average velocity between t equals to 1 and then t is equal to 3? I believe I have a place here. Yeah, let's work there here about this one. The average velocity. I know V average. Average velocity means change in position at or delta S average over delta t, meaning this velocity is ds by dt. Then why don't you say then it's S at 3 between it is given, you see t is equal to 3 and then t is equals to 1. That's what is given. Minus S of 1 over 3 minus 1. And then this is basically, you see now, let me change the pen. This 3, what is the displacement cancel? What is the displacement when S is equal to 3? We just finished. The questions are actually easy. This is the displacement S of, I said X here. And then on the next one, I said S. Let me just, to be consistent, let me use X. What I mean is, V, the average velocity, therefore, is X of 3 minus X of 1 over 3 minus 1. X of 3, we have already had 110 minus, what is X of 1? Put 1 inside there. What did I say? 3 times 1 is 3, plus 1 is 4, plus 2 is 6. That means 6 over 3 minus 2. 100, is it 104? 104 over 2, 152, I believe. It's a velocity. I don't know why somebody who has been in class will make a mistake here. It's just a definition of average velocity. You happy? I hope. If I ask it, guys, did you understand this one? I might be undermining your knowledge. I'm gonna continue. What about the acceleration? I think I had, I left deliberately 3 blank pages. Let's go to acceleration. Again, this is an instantaneous acceleration because it's not average now. At t is equal to 2 seconds, what is the acceleration? But I know my acceleration is dv by dt, rate at which the velocity is changing, or I could say d by dt instead of v is d by dt of x. This is acceleration. You need to differentiate twice. Therefore, those of you not good in mathematics, I'm going to say d by dt of the first x, d by dt of 2 plus 3t squared plus t raised to 4. This is what it is. But if you differentiate this one, first let's do the inside one. What is the differential of a constant number? You must shout in your head by now, I believe. Differential of a constant number is 0 because it's a constant. Then I will say, okay, that thing is going to disappear, the inside one, this one is going to be 0. What's the differential of t squared? I don't know how good your mathematics is. You just bring down that 2, the square t raised to 2. Then I will say this one is d by dt of, this is the outside one, the second one. And then 0 plus 3 times 2, where that 2 comes from is, you see, x raised to n derivative. If you are differentiating this one, this is derivative for me, is n x raised to n minus 1. This is a rule. Therefore, in this case, n is 2. Bring that 2 down, 3 times 2, which is 6. And then t raised to 1. 2 minus 1 is 1. T raised to 1. Plus, I must differentiate the other one. 4 t raised to 3. By now, you must know what I'm talking. Then, if I differentiate again, constant number doesn't give me anything. 3 times 2 is 6. Plus, If I differentiate the last one, it's going to be 4 times 3t squared. By that rule, I'm still applying this rule in. Maybe if I have to say I'm undermining or I'm expecting your mathematics is so good, remember, derivative is distributive. You differentiate d by dt of 2 first, d by dt of 3t squared next, and then d by dt of t raised to 4 last. You distribute the derivative. Again, this is what the second derivative, which is inside. This is your acceleration as a function of time then. Then if I put this equation, it is 6 plus 12t squared. That is your acceleration as a function of time. Okay, then at t equals to 2, it is the question is what happened at t is equals to 2. Then simply insert 2 in this equation. 2 squared is 4. 4 times 12 is 48. 48 plus 6 is 54. Therefore, acceleration at t is equals to 2 must be equals to 54 meter per second squared. I say that. 6 mark for free. Any question here? Please don't hesitate. Even a bit of understanding if you have any question. YouTubers still slow, but you guys, you following up. Thank you for coming in number, by the way. The YouTubers are a lot of them there. Tips, okay. Hartley said I'm happy. Go for it. Good. Other ones, guys, I can't call all of you by name. Okay, Vitevi, thank you, guys. I could see the thumbs up, meaning okay, good. You're going through. Let's continue. I've got an empty page here. Question number 4. Again, think of it. It's a truck. It's a car that covers 40 meters in 8.5 seconds. The distance is given. The time is given. While it's smoothly slowing down, it's decelerating. It's not accelerating. It's slowing down. It's smoothly slowing down to a final velocity of 10.08 km per hour. Who asked me about rounding off? You see here, there is no decimal place here. There is 1 decimal place here. There is now 2 decimal place here. You see, my answer should be with this one has got actually 1 significant figure. Here there are 2 significant figures. Here 1, 2, 3, 4 significant figures. And then I was not told to what degree of accuracy I must be able to express, but I'll take it by a rule. By the rule, then it says the least significant figure rules. But let's continue. What's the question says? What is initial velocity? It's a decelerating, therefore there is a change in velocity. It must start with something. It must slow down to a point of 10.08 kilometer per hour. I hate this one. It's supposed to be in meter per second. Remember, guys, maybe the teacher wanted to check what you're thinking. Always when you see such a number, SI unit, like this one. 40 meter is in SI unit, 8.5 is in SI unit because it's a second. This one, the velocity is not in kilometer per hour, rather it's a meter per second. The first thing you should do is convert that one into the corresponding meter per second. I'm going to go like this. S, or is it along x-axis? Let me say S. Distance is given, which is 40 meter. Good. Time is given, which is 8.5 seconds. Then I know V final was given to me, which is 10.08 kilometer per hour. But I must outright convert it to meter per second. What I do? 10.08 instead of kilometer. I know 1 meter is 1000 meter divided by, instead of hour, I'm going to say 60 times 60 seconds. You know, this is 1 hour is 60 minutes, 1 minute is 60 seconds. You could see where this thing comes in. You happy? Then if I put together, I had that. 1 0, 1 0, 2 0, 2 0 is basically 10 is left there. 100.8 divided by 36. Somebody shout, what is the final answer? Otherwise, I'm going to use a calculator. Not calculator, I don't have a calculator with me. Otherwise, I'm going to use like this, which equals to 100.8 divided by 36. You see, I didn't do this thing. 2.8, that's what I get, meter per second. Therefore, about 2.8 meter per second, I've got the final velocity. Then I'll go back to what am I required actually? The initial velocity, u, I don't know what you guys use, u, and its acceleration. It's not acceleration, rather a deceleration. It's a. It's negative. It should be negative because it's smoothly slowing down. How do I go then? What should I use then? I don't know what depending on what you use. There are so many formulas. Remember? Do it. What I mean, remember is I want to use this one. Should I use S is equals to V initial, which is I say U initial times T plus half AT squared. What do I have? I don't have initial velocity. I don't have acceleration. I have this one. I have time, but I don't have U and A. Therefore, I can't use this one. Two unknowns with one equation. What about this one? Can I use V final square is equal to V naught square? Let me use U. U square plus 2AS. Can I use this one? Maybe, but again it's stuck. This is not known. This is not known. You might say, oh, why don't you solve the two unknowns together? Two equation, two unknown, as you like. But let me give you. But if I know simple equation here, you see it is smoothly slowing down. It's an average. Can I go like this? Okay, can I go like this? What if I say the total displacement must be the final velocity plus the initial velocity over 2, which is average times time? I can't, because this thing is smoothly slowing down. In this equation, if you see, I have almost everything except that u. Then if I use this equation, I could say that 2s must be equals to v final plus u. Then I could see that u must be is equals to twice of the distance minus the final velocity times that rushing, I forgot the time. I'm gonna go back. This implies 2s over t must be is equals to v final plus u. You guys must be easy with that. U must be 2s over t minus v, which I say, what is 2s? 2 times, what are the values? Oh, I don't have on my head. The values are 840 over 8.5, which is 80 over 8.5. 2 times 40 over 8.5 minus 2.8. I remember that one. This everything must be in meter per second. I don't know what you have, but can you do through? Let me just, instead of Excel, I'm gonna cancel that one. This one is gonna be 80 and guys, use your calculator. I believe I got about 6.6 roughly meter per second. Please help me, those of you who have a calculator, just do for me this one. Is it around there? 2 times 40 divided by 8.5 minus 2.8 in meter per second? Maybe my YouTubers have better access. Guys, are you there? Yeah, YouTubers, you are there. Is it alright? This answer, 6 point something? Okay, around there. No problem. Let's continue. Then we got the, what we're looking for is in original velocity u, and then let's go to acceleration. If we got that one, the acceleration should be easy because we kind of have the close by. Then which formula I'm going to use? and it depends also what are we going. What happened? Do I have a page here? I don't have a page. Then acceleration, I'm going to say, oh, let me use this one rather. V final must be equal to V naught u plus at. Then this implies that the acceleration must be V final minus u over t, which is going to be 6.6 minus 2.8 over, what is that one? No, it's not true. That's why I hate running. The final is actually the small. 2.8 minus 6.6 divided by the time is something, what is 8.5. And then I could get that it should be negative anyway because it's slowing down. And I could see 2.8, 6.8. I don't know what you guys gonna say. What is the value? Why don't I put it here instead of begging you? Nobody shout. Equals to 2.8 minus 6.6, which is equals this one divided by 8.5. It must be about 0.44 or 0.45, negative 0.44 or 4.45. I don't know which one. Meter per second square. I must be specific. You see now, as I said, if somebody want to join a Teams, and why you ask me? What is this saying? Somebody want to invite a share. Okay, go for it. Okay, guys, sorry, I'm communicating in between also. Somebody want to share a link. It's no problem. You guys, you can directly share the link. Okay, and why I came back is actually how many significant figures should I stop? This one give me 4, 0, which is one significant figure. If you are restricted, I could say this one 0.4, 0 around. If you are specifying properly, acceleration must be about negative 0.4 meter per second square, because I only have one significant figure in the calculation. This is the one significant figure. Here I've got two significant figure. Here I've got 4 significant figure. Therefore, my final answer should be close to the least significant figure. But as long as the teacher is not pushing you to express, don't worry about it. This is all about question number 4. Let me hold in between in case, guys, you wanted a question. Tabiso, you are admitted. Somebody who just want to join again, you are admitted to the meeting. You welcome. Okay, Tabiso, welcome. Guys, are you happy up to question number 4? Do you have anything to say? This is basically a very simple question though. Rather, less. This one is a bit tough. Okay, Rafaelo, thank you. And guys, for those of you thumb up, happy. This is a bit tough question. What if you are writing this particular question? What could you have done? Let's see what the question is. It's a ball which is thrown from a window of a building. It's a ball which is thrown from a window of a building. Of course, you could feel at this stage that it's a projectile motion. The ball is given an initial velocity of 8 meters per second at an angle of 20 degrees below the horizontal. You see, you have to read this one thoroughly. This is my y coordinate, and then let's say this thing is thrown from a building, and then if this thing is a horizontal x-axis and that is a y-axis, and this ball is actually thrown at on this coordinate below x-axis in this direction with angle of 20 degrees. And then it says, because this thing is kind of a projectile motion, it goes and then strike, like the distance, is it given? Now, the time it takes for this time of flight, t equals to 3 seconds. This is what is given. And then the initial velocity with which this ball is thrown, v naught, let me use now, v naught is 8 meters per second. Then it asks, the question number A is, what is this range R? Or how far does the base of the building that the ball struck the ground? 2, the next question is, how high? Find the height from which the ball was thrown. What about this one? This edge. What could you have done? How should we go forward? Suggestion, or should I push? What you should do? You see, if I put you a bit back, question number 3 and the question number 4 is actually motion along one dimension. 2, 3, and 4. Question number, where is that? Question number 2 is a vector. Question number 1 is from unit 1. I'm just dragging it through. Unit 1, or vector, that's all about the vector. Motion in one dimension. Question number 4 is also motion in one direction. Now this one is motion in 2 dimensions. What should you do? In this case, remember what we agreed. Either Dr. Lindsay or Professor Tim also, as they took you, this projectile motion, you could consider it's a 2-dimensional motion whereby the x component and then the y component are separately treated. For the x component, there is no acceleration. For the y component, there is acceleration, but it's always in the negative y direction. This acceleration is acceleration due to gravity. With these two concepts, meaning the x component is a uniform motion, there is no acceleration, and the y component actually involves acceleration, however, the acceleration is due to gravity. Mashaba, you want to say something? Mashaba. Mr. Mashaba, do you want to say something? I could see your mic on and off, that's why I'm picking you up. Yeah, no problem if you don't have question. Good, let's go. Then, as I said, then to do that, the R is related to X, the X component I'm talking. Therefore, this is actually V naught X times T. Because it's uniformly, not uniformly accelerated, it's a uniform motion, no acceleration. Then if I know the time, if I know V naught along X, I must be able to see that distance R. The Y component is an acceleration. I will say V naught, is Y naught plus V naught Y times the T plus or minus half GT squared. This is the two questions that I hope you guys have during the projectile motion. Somebody raising hand? Temba? Petros? Mr. Petros? Temba? Yeah? We consider negative if you throwing this thing up, the gravity is always pulling you down. Therefore, for an object that moves along the y-axis up away from the surface of the earth, the gravity is negative. Indication, it's pulling you down. However, if you are throwing it down from a building, straight down, in addition to your energy, which is you throwing with, the gravity is also pulling it more, therefore acceleration is plus. Therefore, you use plus when the object is moving down, and then you use negative when the object is moving away from the surface of the earth. Basically, due to gravity. When it's going down, it's not negative. Let me write for you. Y up. If it is up, I'm going to write Y naught plus V naught Y times T minus half gt squared. That is your equation if it is going up. If it is going down, y down must be is equal to, just hold on, let me admit somebody. I don't know why they ask. Asanda, you are in. Y down is gonna be y naught plus v naught y times t plus half gt squared. This is for down. It's not always negative. It's negative when it is up and positive when it is down. Okay, good. You're welcome. Therefore, with this assumption, the only thing left for us is, therefore, we don't know what is v naught x and v naught y. That is the only thing missing. But you could see here, the x component is going to be that way, the y component is going to be that way. Then I could simply say that the v naught along x is actually v naught cosine of that angle, 20 degree. And then v naught along y is going to be v naught sine of 20 degree. But if I use this concept, remember when I said I'm going to confuse you, where I know that the x component is positive and the y component is negative, because the y component is down, the x component is positive to the right. If you don't want to confuse yourself in such a way, just take this angle. The angle is going to be this much. That angle going to be 360 degree minus 20 degree, which is 340 degree. And instead of writing 20 degree and then putting a minus and a plus in front, you could say 340 degree, 340 degree, and then forget about the positive negative sign. But also, if you just say, the x component is to the right is positive, the y component is down, which is negative, I could simply use the 20, you're welcome. And remember, please, the x component have no any acceleration, therefore the term cancelled there. It's actually v naught x times 3 plus half at squared. Because there is no acceleration along the x-axis, we don't consider the second component. Can we go forward then? If you accept that r, which is the x equals to v naught, which is what we given 8 meters per second. You guys update me now. I didn't do this thing on calculation. 8, 20. Okay. V naught x must be 8 times cosine of 120 degree, 20 degree, and times the time is 3, therefore is actually 24 times cosine of 20 degree. Again, I don't know why people come in the form of guest. I've invited, they're supposed to get it in. Okay, you are somebody who just has joined us, you're welcome. What do you get this one? Can I use, okay, I'm gonna use my phone as a calculator. What is cosine of this one? You guys, I wish you help me. And I get about 22.55, is that true? 25 meters. You agree? Yeah, thank you. Gosana, Hetri, those of you thumb up, thank you. You following up. Then let's go to the y component. The y component, this is, you see, you guys, you might struggle to find this y component. You should not worry even. Good. Thank you. Thank you for those of the time. Let's just continue with it. I don't know, you could use so many equations here. But if I go back, I'm going to use exactly this one. It's coming down. It's coming down. And then let's do even a nice mathematics. Because it's coming down, it starts from that height. That y naught is actually h. Then when it go reach that the y, remember our origin is here. Our origin is there. That is a starting point, 0.0. But when it come here, it's going to be negative h. Okay? Can you go that way? Or you simply say, no, okay, the displacement that it goes is basically from there to here. What if I go like this? Okay, let me not confuse. I'm going to go that the y, the displacement y is equals to v naught y times the t plus half gt squared. Look what I used. If you use negative, you end up a small number. Mashaba, you see, I'm not using always negative, rather, because it's coming down, I put positive. However, I must use whatever I have now. Okay, thank you, Mashaba. I have everything, but remember, my y component is negative. I should be careful here. Thank you, Gosana, also. Those of you, thumbs up. I should be careful. I'm going to put minus 8 meter per second. That's the velocity. Sine of 20 times 3. This is v naught times t, which is 3. Plus, not plus or minus, only plus half. G is 9.8. T is 9. T square is 9. I'm just multiplying in my head. T is 3, isn't it? Yeah. T square is 9. Therefore, you see, careful here. I put negative deliberately because I know the y component has got a negative over there. Again, if you please don't have calculator, as I said again, it's gonna be 8 times sine 20. As you have calculator, you could go ahead of me even. I get okay, sine 20 times 8 plus half gt square. Half is 4.2 something t square. Okay, I got about 52.32 meter, but negative. Did you get the same? Rosana, you get the same? Good. Negative. You see that negative actually is telling me that your answer is supposed to be 52 meter. I'm gonna put positive, and then why I say 52 alone is nobody gave me the significant figure. I only have one decimal place here, and therefore I can't help. Even if you round it to the nearest 10, it's gonna be about 50 meter. You see, to have one decimal place, but 52 is a good answer. I remove negative because of the following. Remember, my origin is there. This thing is down. That's why my answer becomes negative. But the correct answer is actually the height, the absolute value of the displacement. The height must be about 52.32 meters. Happy here? Maybe I left my YouTubers in vain today. YouTubers, thank you. I know I left you behind, but I hope you guys are picking up. Well, yeah. Okay, question here. Any comment up to now? Gosana, thank you. Good. Guys, I can't see those of you there. Only some is on the screen, but there are 24 plus behind. Those of you are listening, thank you for coming in numbers this morning though. And therefore, if I don't see hand or if I don't see on the chat, let me check the chat. So far so good. I don't see any. Good, let's go. Oh, I've got empty page here. This is the last question on this PHYV test. And again, you see, question number 5 and 6 is two-dimensional motion. This one is circular motion in principle. More of conceptual, I believe. Yeah. I was in the, as I said, I was in the invigilation room. I read through this thing, and then I saw so many students making mistake here. The following figure, which says is an overhead view of a ball on a string moving in a circular path. Think of it, you tie a ball by a string and then make it on your head. You're making it in circle. You can't see on Teams. My video is only shared on YouTube. But basically you could imagine that you have a string and then you have a ball at the end, and then you kind of rotating it above your head, and then overhead view you could see that the ball is moving with constant speed. Professor Tim, you see what it does to them? He said to them, it's a constant speed. And then question number 1 says, is the ball accelerating? What would have said? Please, there is no workout here. It's just a conceptual. Is the ball accelerating? Yes or no? If yes, why? If no, why? Question number 1 and 2. Roman number 1 and the Roman number 2. What do you say? Let's see question number 1. Is it accelerating? Guys, I've got more than 24, 5, 6, 7, 8, 9, 10, 11, 12, 13, about 40 something students are there on the link. Is it accelerating or no? Let's raise a hand. Accelerating, you say thumb up if it is accelerating or no. Let's say accelerating. Thumb up, I'll count. Accelerating. 1, 2, 3. I'm counting. Okay, at least 4 coming. Yeah, 5. Earthly. Okay, good. Okay, guys, those it's blink. I can't count now. So many. Okay, somebody who want to ask a question? Temba, you want to speak? Somebody raise the hand. Okay, Temba, I believe you wanted to raise thumb, not hand. Okay, Becky, you want to say something? If you raise hand, it means it's a question for me, Becky. Oh, is it a misuse of thumb and the hand? If you raise hand, it looks like you have a question. I'm asking you, Mr. Becky. It's a mystery. Yes, Becky? Mulanga? Malangu? Sound is small if you're speaking. I know your mic is on, but I can't hear you. Pumalelo? Pumalelo? Yeah? Guys, okay. Somebody was raising hand, but I can't reach you. Okay, good. Those of you who said accelerating, but let me confuse you. But it's a constant speed. How do you say it's accelerating? We know that the acceleration is defined as v final minus v initial over t. But it says a constant speed. Why you say it is accelerating? Temba, you want to come in? Yeah? You coming in. Thank you. You're saying because this thing is undergoing a circular motion, even though the speed is constant, the acceleration is changing as a function of direction. Nkosana, you also said yes, he's right. Yeah. Lufaniso, you also clapping hand. Yes, most of you. That is exactly the answer. Yes, it is accelerating. Why? Even though it is undergoing a circular motion with a constant speed, at each point the direction of the ball is changing. That indicated that the acceleration is there. It is accelerating. Then we are happy. The answer is because of the change in direction. Then the last one, it says, oh, it's actually showing. Show the direction of the ball. Show the direction the ball will move if the rope breaks. Let me give you now, because you can't show here. Can I say, if it is released, if the string is cut, is it gonna go 1? This is case 1. Is it gonna go like this, case 2? Is it gonna go back that way? Case, not that case is bad actually. Tangent, case 3. Or what happened? What other option do you have? Or it's gonna kind of go like this. 4. Which path is yours? 1, 2, 3, or 4? Let's say 1. If you cut the string here, don't cut it. It's gonna fly out. Therefore, who say pass number 1 is correct? Let's hand. 1. Somebody thumb up if you say 1 is correct. 1 is, by the way, what I'm sharing here. Nobody want 1. 2. Becky, you still struggling? I know what happened. I don't know. Auntie? Somebody want to speak? Themba also, you raised the... Oh, Themba, you took off. Okay, Themba? Themba, come on, please. Number 2, why? Why not number 1? Because the road is, the string is cut off. Why didn't fly out? It's perpendicular to the radius. I see where you're coming. Who else may come in? Themba, I see where your view. You have got a nice eye. Somebody, any other comment? Why don't you don't want the 4? Why you don't want 3? 3 is wrong actually. I could easily see that. How is the ball gonna go back? It's gonna continue either pass 1, part 2, or 4. Why didn't go in the form of like a curved path? Why to go straight? Is the following. I think Themba said very well. Remember, at every point on a circular in a circle, if an object is undergoing a circular path, at every point there is a so-called centripetal acceleration, center seeking, which is a centripetal, which is v squared over r, and then it also has a tangential component, which is a tangential, which is omega, the angular frequency times, you see, acceleration is equal to v initial times t plus half at squared, but I'm going to use that one if it is not accelerating, omega times t, you see, or omega times r. If you go through this one, by the way, I forgot even the derivation, there is a tangential component. As Themba said, at every point this tangential is 90 degrees with respect to the radius. Therefore, if the string is cut, the centripetal acceleration is 0 because there is no any more pulling it in. Then the tangential component causes this object to continue moving, but tangent to the circle. Where that tangential, is the angle between the radius and then the curve that the particle takes, or this in this case the ball takes, is 90 degrees. Therefore, pass number 2 should be the correct answer. What do you say? Basically, this is all about the test that the PHYV 101 students are wrote. Any question you want to raise in between? Otherwise, we are almost as good as done here. And if I could see you guys, and especially PHYV, not PHYV, FEVV student, just hold on. Let me show you what happened to me last week. And I have gone through a physics workbook part B. Just hold on. And I'm going to zoom a bit in. Section 8 point something. I made a mistake. Not a mistake, but I supposed to give something there. Where is this? 8 point something. No. 8.4, I believe. Yeah, is it here? It's about a person pushing something. Is it maybe here? No, still yet. Just hold on for me. I'm gonna go fast. We go through this all problem. Where is this? Not the 9, I know. Here. Just keep an eye there. But let me go to the question first. This is where I was stuck and I said, what is Dr. Lindsay saying? Look, it says calculate the tension in the street. No, it's not about this. It's a person pushing something on ice. What is this question? Yes, this one. Just let me zoom in first so that we read together. It says a contestant, somebody who is contesting in a winter sport event, pushes 45 kilogram block of ice across a frozen lake as shown in the following figure. Let me go back to that figure, then I'll just to bring you. This is the figure she's talking, figure A. He's pushing this ice on a frozen lake. The angle at which he is applying a force is 20 degrees. And let me go back to the question now. Going up like this, visible for everybody. Then now if I draw that drawing, this is the ice, and then the force applied is in this direction. The angle is 20 degree. 25 degree. It has got a mass and then it's moving. The question she asks is calculate the minimum force. Look there, calculate the minimum force F he must exert to get the block moving. It must just start moving. You see something that was not given here. The static friction is not given. And then when I went out from the online seminar or online teaching, I said, okay, what is the friction, coefficient of static friction? And I forgot that, I didn't have in my head. When an ice, this is ice, and then it's also on ice, and then the coefficient of friction is known. But how do I keep in my head? It has to be specified in the question also. The coefficient of static friction mu is actually 0.1. I said last week when we were doing this tutorial, I said I don't know what the mu is. It's supposed to be given. But for you, just to give you an idea of what we're supposed to be doing here, this is an object, because it's an on-flat object. There is a normal force N. There is an F cos theta, which is pushing, F cos theta. There is mg down. And then again, because this angle is at down, this person is applying the force in this direction, the y component is also down. That means F sine theta is also down. F sine theta is down. Then for this object to start to move, F cos theta minus mu times frictional force. That frictional force is going to be in opposite direction. Obvious, must be equal to 0 for it just to start moving. If you put together now, F cos theta must be equals to mu times norm F. But what is that F? Remember we said F, the frictional force, is mu times, now I'm teasing, not like that. This is, you see, I'm also rushing here. Actually, F minus the frictional force, like this. But that F is mu times normal force. What are the normal force? Because this object is not going up and down, the normal force must be equals to mg plus F sine theta, both of them, which I say is equals to mu into mg plus F sine theta. Then if you put this thing together, F cos theta must be equals to mu mg minus or plus mu F sine theta. You see? Then I don't have a place to write. I'm going to come it here because I don't have any pen here, free paper. Then I will say F into cos theta minus mu sine theta must be equals to mg, mu mg. This is what I derived last week also. The F must be equals to mu mg over cos theta minus mu sine theta. Using that the knowledge ice on ice. This is ice, lake is also ice, mu supposed to be known. I don't have in my head last week. Is 0.1 now. I read about it. 0.1, if you put this one, the answer is 51 Newton. That's all what I said. This is, if you have, let me stop here. For my side, I'm done. PHYV tutorial, what's that? The test number 1 we have gone through, question 1 to 6. This is the one in my head which I missed last week. If you could continue now, if you are still busy with, what about if it is pooling? F sine theta is gonna be, that is pooling. Let me just come here. F cos theta is that way, F sine theta is up. If it is pooling, that equation now, the one we just derived here, is not gonna be minus, it's gonna be in opposite direction plus. Otherwise, I'm done on my side. Do you have question? If you have question or discussion, especially those of you FEVV student who will be writing the test now in this week, you are welcome to ask me any question from any past or whatever. Or FEVV students also, you are welcome to discuss anything. And on my side, I'm done. Thank you for coming in number if you are leaving me now. Otherwise, thank you. I'll be just holding on if somebody want to say anything. Otherwise, guys, thank you for coming. I'm gonna just wait for a minute or so in case somebody's shy, you don't want to speak, but they want to come in now. You are welcome. YouTubers, because you can't communicate with me anyway, I'm gonna stop the broadcasting now.